All right, well, it is time to do Lesson 5.5, and I've got my usual friend Ben here to help me, and we're going to be talking about customary units and dimensional analysis. And I'm going to put this right here so that when you do talk, we can hear you nice and loud, okay? All right, so we've already done measuring, and we did all kinds of metric units. We did centimeters and meters and kilometers, and we did grams when we were talking about mass, and we did liters when we were talking about capacity.
Isn't this almost relative to like that one we did with millimeters?
Yeah, it kind of is. So what we did in that lesson is we changed from one type of unit to another. So we changed from millimeters to centimeters, or centimeters to meters, or meters to kilometers, or back the other way. Okay, and all we had to do was King Henry died by drinking chocolate milk, which was count a couple decimal places, move the decimal back and forth, and we were done.
Yep.
No such luck with customary units. The only way to change customary units from one into another is we have to know, first of all, how many of them there are, and they're all different numbers. We have things like 3, 12, 16, 2, 4, 5,280, 1,760, 16, just to name a few of them. So you have 2,000. You have to know how many of the small unit go into the bigger unit. And then, to do the conversion, you have to do fraction multiplication, which is why we're doing it right now. So, as usual, a lot of times we'll have a unit like this that seems really random. Like, why did they drop this in right now? Well, because the way we're going to do dimensional analysis this whole second half is by multiplying fractions. So let's get right into it. Customary units, like Ben just said, we are going to revisit the 3 different kinds of measurement, which are length, capacity, and weight or mass. Okay? All right, and so very quickly, starting with length, in the metric system we use things that ended with meters: centimeter, millimeter, kilometer, meter. Okay? In customary units, there are also units we're very familiar with. They're things like inches, feet, yards, miles. There's also some weird ones like rods, furlongs. No, that would be metric. Leagues. Knots, hands is one that outside of Kentucky probably nobody would even know that to measure how high a horse is or how tall a horse is. Furlongs and hands. Actually, the interesting thing, these two in the middle, these are very unique to Kentucky because they have to do with the horse racing industry. All right, so that's ways to measure length. In terms of measuring capacity, there's a lot more of these. It was all the stuff that ended in liter when we were in the metric system. Now we're talking about fluid ounces, right? Cups, pints, quarts, gallons. And then we have some weird ones here too. We have teaspoons and tablespoons, dashes, pinches, weird stuff like that. And then finally, weight, or really mass, because weight is just gravity pulling on a set mass. So really what we're measuring is mass of something on the surface of the earth. And we use ounces, pounds, and tons. Those are not quite as fancy. That's actually the simplest of all the stuff up here. All right, let's revisit capacity for a second, because there's a couple different ways to remember those. Like we just said, the weight, there aren't that many. They're pretty easy to remember. Okay, it turns out that there are 16 ounces in 1 pound. Okay, and that there are 2,000 pounds in a ton. Okay, at least in a short ton. There's also a long ton, which is 2,200 tons, and that actually has more to do with the metric system than it does to have with the customary units. And then up here, inches, feet, yards, and mile. Well, again, we use those a lot. So even though it's kind of ugly, we know there's 12 inches in a foot. We know there's 3 feet in a yard. Why is that not working? Okay. We know that there's 3 feet in a yard. And we don't really know, most people don't know how many yards are in a mile.
Isn't it like 2,000?
It's like 1,000. It's 1,760. But we should know that there are 5,280 feet in a mile. So we kind of skip over the yard. Oops, I kind of drew that wrong. Well, I drew the arrow. I guess I got to go back up. I drew the arrow.
Oh, at inches.
Yeah, actually I drew it from inches. So there's a lot more than that inches. All right, is it going to back up for me? Here we go. All right, so yes, so this should have been, this is more trouble than it's worth. This should have been 5,200.
Thanks, Doshiri.
Okay, here we go. All right, let's go ahead. So let's focus on capacity for a second, because honestly, this is the one that's the most confusing because it keeps changing. There's 2 ways to remember this. one way is to start with a gallon, and the gallon is going to be like the body. And this is Gallon Man. All right.
Oh yeah.
Now Gallon Man has think of bones, the arm bones and the leg bones. The first bone before you get to the elbows and the kneecaps is a single bone. Okay. Think of those as the quarts. And so as you go around Gallon Man, each of them, it takes 4 quarts to make a gallon.
This is your.
But then when you go a little bit, when you go a little bit further out on the arm, you get the radius and the ulna.
Yeah.
Okay, so the radius, there's 2, right? So those are, consider those pints.
Yeah.
Okay, and it takes 2 pints to make 1 quart. So down here you have the tibia and the fibula.
Fibula.
Okay? Fibula, right? Because the big one's the femur. All right, and so same. All right, so for each of these joints, the bottom, the outer extremities are 2, and those are going to be like the pints. So 2 pints make a quart, 4 quarts make a gallon. Now, if you zoom in, I'm not going to draw all of these, but if you zoom on one foot, let's say that we've lost all of our big toes and thumbs, and let's just put 4 things out here, and those are going to be the cups. So imagine that the Gallon Man has 4 fingers on each hand and 4 toes on each foot. Those are going to be the cups. Okay, and then if you want, you can go ahead and you can give Gallon Man a big hat, and you can say things like 16 fluid ounces equal a pint. You could give him a briefcase, and you could put something on the briefcase or a shopping bag, so that you can put you could squeeze other things in here if you wanted to. Now, there's another way to do this same diagram. This is popular in everyday math, so you might have seen this too. You start with a big square G like this. And I'm going to use the same color coding. Then the gallon splits into 4 quarts. So you fill in the G.
That looks weird.
Looks kind of like.
I've seen that before.
All right, with quarts, and then you fill in each big D with a big P.
I think everyone.
And so we can see, so you can see that there, and then finally you fill in the pint. You fill in the circle with a C, and then you put another one down by the tail. All right, and so you put these, and these are the cups. So this would be like drawing all the fingers on. So if you want to break it down, a gallon is 4 quarts. Each quart, so focus. Each quart is 2 pints. Each pint is 2 cups. If you want to figure out how many cups are in a quart, there's 4. How many cups in the total gallon? 4.
16.
16, good. How many pints in the whole gallon?
8.
The purple, yep, 8. All right, you got the idea. All right, so this is a way to help you remember the capacity. You can draw the little guy, or you can draw this. They both basically show you the same thing.
You know, there is another way.
Yeah, no, we're not going to get. Let's not get into that right now. All right, I'm trying to keep this video under 10 minutes. So finally, we get to the conversions. All right, so if you want to convert from one unit to another unit, here's what you do. Suppose that you are, I don't know. Let's say we've got 3 quarts, and I want to change that into cups. All right, so here's what you do. You multiply by a fraction. So you put this over 1, make it into a fraction, and you multiply by a fraction. And first, let's figure out the units. We're going to put quarts on the bottom. And the reason quarts go on the bottom, whatever you start out with, you want it to cancel out. And anything on the top and anything on the bottom can cancel, so including labels. So we put whatever we start with, we're going to put down here on the bottom. Now, what are we changing it into? We're changing it into cups. All right, so now, all we did, we start with the bigger unit. The quart is bigger, so it's 1. You put a 1 there. Not necessarily starting on the bottom. It's whatever is bigger. You start with a 1. And then go back for a second. How many pints were in a quart?
2.
2. Okay. So for each quart, that's the same thing as 2 cups. So what I'm really multiplying by is really the fraction 1. Because 2 quarts is 2 cups is the same as a quart. I'm sorry. No, we were changing it into cups. There were 2 pints in a quart.
2 pints.
I'm glad I caught that.
There
are 4. Yeah, there you go. There are 4
cups.
4 cups in a quart. All right, now we multiply the math. Let's start with the units. Quarts and quarts cancels out, so we're going to be left with cups, which is what we wanted. And 3 times 4 on the top is 12, with a C for cups. And 1 times 1 on the bottom is just 1, or you can just write 12 cups. Okay, so what we're going to do is we're going to use a fraction multiplication to do all these conversions. Let's do an easy one. Let's say that you know somebody on the UK basketball team is 6 feet tall, and I want to know their height in inches. So put that over 1. Again, we're going to put the feet on the bottom, and we're going to put the inches on the top.
Don't forget the labels.
Okay,
That could be
exactly.
forgettable.
And we're going to start with the bigger unit, which is foot, and a foot is 12 inches. And so the labels cancel out, and 6 times 12 is 72 inches.
It's a lot
All
easier.
right, let's say we're going the other way. Suppose that we are at one of those amusement parks, and they tell you that you have to be 54 inches tall to ride a ride, and I want to change that into feet.
So you can understand.
Yeah, so we know exactly how tall that is, because I don't think in terms of 54 inches. All right, so now we're going to multiply. This time, we're going to put the inches on the bottom, and we're going to put the feet on the top. We always start with the bigger unit, so the 1 this time goes on the top, and the 12 goes on the bottom. And now what I do is I multiply across. Now, before I multiply, do you see anything that cancels?
12 and
Inches
54.
cancel, and the
And
12 and
inches.
54 are both even, so take a 2 out, you get 6 and 27. 6 and 27 are both divisible by what?
3.
3. So take a 3 out, and this will become 2. Now, by the way, be real careful. I keep seeing this on people's papers. When we take a 3 out, we're dividing by 3. I've had a lot of people been writing things like 3 down here because they're thinking, okay, I'm taking 3 out, so they write the 3 down. It's what's left after you take the 3 out that you want to write down. Same thing up here. Take a 3 out, and you'll be left with 9. So now I've reduced this down to 9 over 2, and I'm left with feet. So that actually is exactly 4 1/2 feet
So
tall.
4.
Or I could also change this into 4 feet 6 inches. Either one would be
4
fine.
1/2.
Okay, so 4 1/2 feet. That is an example of dimensional analysis. All right, we're going to give you one more example before we go, and this is how dimensional analysis can get a little hard. Suppose we do an experiment where we measure, let's say we've got a dog, and the dog is walking down the hall. Okay, and he's not really running, but he's not walking slow, and we're having trouble keeping up. And we find out that the dog is walking 10 feet per...
Second.
Well, that's too fast.
Yeah, I know. That would be like...
Let's see. All right, let's slow it down a little bit. Well, we could make it per minute, 10 feet per minute, but that's not fast anymore. That's really slow. So let's say we've got a big snapping turtle. We'll change it from a dog to a snapping turtle.
Okay.
So we put the snapping turtle in the hallway, and we just kind of observe it. And each minute he gets about 10 feet down the hall. We want to know how many miles per hour he's moving. All right, so we've got a couple problems here. We don't have miles, and we don't have hours. So we've got multiple conversions that need to be done here. All right, so let's do one at a time. Let's start with the feet. We want to change feet into miles, so let's use what we just said. Feet goes on the bottom. Why? Because that's what we're trying to get rid of.
Oh, yes.
And we're going to change it into miles, which is bigger. Miles bigger, so 1 goes on the top. And you got to memorize that 5,280 feet go into a mile. That's one you're going to have to memorize. All right?
Yeah.
That will, now look, just focus on the units as we go. Feet and feet will cancel out, and sure enough, we're left with miles. Now let's fix the time. We don't want minutes, do we?
No.
So let's put minutes, since minutes is on the bottom right now, and we want them to go away, put them on the top. And then they'll cancel out. What do minutes change into?
Hours.
Hours.
But
Okay?
Only
So,
6.
and the bigger unit is 1 hour, and there are 60 minutes in an hour. All right? So now, when I multiply across here, well, look at all those things that end in 0. Let's do some canceling here. All right, so first let's cancel the 10 and the 5,280 and make this 528. Agreed?
Yeah, it's a lot
Okay,
easier.
the feet and the feet cancel, the minutes and the minutes cancel. All right, now 528 and 60 are both even numbers, so let's take another 2 out. This will be 30, and this will be 264, I believe. Yes, that's right.
Yeah,
And they're still both even, so take another 2 out. This is now down to 15, and this will be 132. All right, now 15 is not even anymore, but it is divisible by 3, and so is 132, right? Because it adds up to 6. So take a 3 out, and we get 40.
Using those divisibilities.
That's right, they're really handy. We're taking 3 out, so we get 44 here, and we take a 3 out here, we get 5. All right, I think we're done. So now we get what's left on the top, 1, 1, and 5, so this is 5. And on the bottom we have 1, 1, and 44. 5 44 miles per hour. And, oh, hold on, let's double check. Okay, so yes, and the only units that were left were miles and hours. So that does check. And so that's, let's see, that's about 1/9 of a mile per hour. which is really, really slow. But again, we're talking about a turtle, so that makes sense.
Yeah.
Okay, so that's the idea. And we could start with a faster time. Maybe we did something where we measured in seconds, and maybe something's going 2 feet per second. Well, then we'd have to change the seconds into minutes, and the minutes into hours, and we'd also have to change the feet into miles like we just did. Okay? You don't need to memorize, though, whether you're multiplying by 5,280 or dividing by 5,280. Instead, just use the fractions to line up the problems. And this is called dimensional analysis. All right, we just hit 15 minutes, so we're going to call it a video. Thank you very much for watching. We will obviously be practicing this in class tomorrow before we head away for Thanksgiving break. So this is Mr. Gunn.
And Ben.
Signing off. Take care. Thanks for watching.
Good night.